Good morning. I'd like to welcome you to our digital classroom. I'm Jerry Winslet, along with Kevin Binkley. And today, Kevin, we're going to be talking about the heat pump. And, you know, with NECA 3 coming and all the different options that we have out there, especially like on the electric side, assuming, you know, that anything over 50 gallons, 55 gallons is we're going to have to go to either a different technology or heat pump. Let's talk about the heat pump, and let's talk about, you know, really how does it work, and how is that important for like a customer?
Well, the way a heat pump works is it's a little bit different than a residential electric. What it does is it has an evaporator on top, and what it's doing is it has this fan in it as well. And what it's doing is it's actually pulling the heat energy out of the air around it, okay, and it's transferring it to a condenser that's wrapped around the tank, okay, and we're transferring that energy to the actual water itself. So what you're going to notice that's different is the unit's going to run a lot longer. The benefit to you is this means that you're saving a lot of money.
Right.
So, you know, what will happen is this guy's going to run, you know, especially if you're in hybrid or efficiency mode, you could run, you know, several hours. Okay, so we're actually taking the heat that's in the air or in the ambient temperature in the room, that heat, and we're transferring it into the water. And it's basically you've got up here like a reverse air conditioner. You know, if you ever see a wall unit or a window unit, you know, you're blowing out that heat on the outside, and then there's air-conditioned air coming inside. So it's basically backwards. We're taking that heat that we're blowing out, and we're putting it actually into the water by using that coil and heating the tank. That's right.
You know, so talk about, you know, you're going to need to move a lot of air. So we're talking about how much air do we actually have to have, or what kind of space do we need to install one of these?
Well, that's a valid point, because, you know, with a regular residential electric, you know, as long as you could fit it in, you know, that there was nothing, you know, nothing else to take into consideration. Right. With this guy, you have to have about 750 cubic feet of air around it in order for the heat pump itself to actually work right, you know, because we don't want, you know, mold or anything like that, or any other concerns. So that's the reason we have the space, you know, requirements that go along with this versus a standard residential electric.
Yeah, so we're going to have to make provisions for that. We're going to have a big enough room. If we're putting it in a room with a door, then we're going to have louvers large enough to where we can pull in that much heat or pull in that much air and put it into the heat, into the water. So things like that we're going to have to keep into consideration whenever we're going from electric to a heat pump, a large enough room. So we're actually taking that air, passing it through a filter and going into the coil that way. Now, it comes with several different. Another thing too, well, there's got to be a fan on there, right? So it's going to make some noise, which is different than having a standard electric water heater. Let's talk about that fan and how loud that is.
Well, the fan itself is going to be up around 51 dBA, which makes about as much noise as a quiet suburban neighborhood. I mean, you know, if you've got like a refrigerator in your home, you're looking about at the same noise level as your refrigerator makes.
Okay.
You know, so that's something, you know, you may want to educate the homeowner to, that, you know, because they're used to a traditional electric water heater that
didn't make any noise.
Didn't make any noise whatsoever. You know, and this one's going to make a little bit.
Yeah. And okay, so if we're taking the heat from around the water heater, putting it into the water, is there any parameters? I know that there are on temperature of the ambient, you know, air coming into it. So we're looking at anywhere, it's going to operate anywhere between 45 degrees and 109 and up to 120 on the 50 gallon.
That's right. The reason 45, really, there's not enough heat energy in the air to actually, you know, make it efficient to run the heat pump. And then once you drive above 109 or 120, you run into the danger of getting that compressor and the other components on it too hot. So you want to lock it out and let the electric elements actually take over and do the heating then.
Okay. Then we're going to talk about how this works, and because we do have electric heating elements on this, and we use the heat pump. So let's talk about the different modes that are available and how they operate. Let's start with efficiency.
Sure. Efficiency, what this is going to do, this is actually your most efficient mode. It's going to run in the heat pump mode all the time, as long as you're staying within those temperature parameters that we just mentioned. You know, the trade-off to it is you're going to save more money as far as your electric rates. All right, but like what's going to happen is it's going to take a lot longer to recover. For a typical family of 4, you know, let's say everyone gets up in the morning and takes, you know, showers, as long as you've got that 8-hour period or 9-hour period for it to recover, all right, and then everyone comes home and you have another peak usage, you know, you could actually probably get away with using just efficiency. Yeah. What we actually suggest, though, is going to be the hybrid mode.
Okay, and that's a different mode, and that's got to be a combination of both. You know, efficiency would be good, though. I mean, if you did on a standard, you know, family of 4, they get up, people go to work, go to school, they take showers in the morning. We're looking at an 80-gallon tank here. So, you know, the initial, you know, load in the morning, this will give us around 81 gallons, or excuse me, 91 gallons in the morning of hot water. So that's good, enough to take those showers and get out the door. Then it has all day to go ahead and recover, and that would be a good mode. But now we're talking about hybrid, which is kind of a mixture of both. How does that work?
Sure. Hybrid, the way it works is you're going to be working a combination of both. We're going to run on heat pump, okay? But let's say, you know, that people get up and you start having back-to-back showers. And let's say the tank starts to see a rapid or big drop in temperature. Let's say, you know, you have it set for 120 and it sees that temperature all of a sudden drop, you know, to a set amount. I think it's around 59 degrees coming in. It's automatically going to kick on and kick those elements on. That way you get the quicker recovery, and the heat pump's going to run as well.
Yeah, because I think what happens is the heat pump's going to kick on and around when it drops about 20 degrees in the tank. Heat pump will kick on, and then if it drops another 20 degrees, it's actually going to kick on the elements at the same time, and both elements will come on at the same time, correct?
Well, it's going to work like the old style electric. You know, it's only going to come on one element at a time, and there's thermistors high and low. That's going to, you know, based off the tank temperature, and that's the element it's going to energize.
So below the heat pump part, up here, below the shroud, we're looking at just a standard electric water heater that has thermistors, immersion thermistors, that are actually sensing the water temperature in the tank.
Right. Basically, after you get past this, you would troubleshoot it like you would any other residential electric water heater.
All right. All right, because so a hybrid mode would be a good mode to have it in if you have family over, or actually probably a good mode to run it in all the time because you would get a little bit more hot water out of this unit.
Well, and that's the reason we suggest, that's our suggestion is running it hybrid, is because then you get the cost efficiency. You know, that's a huge feature with this guy as far as the energy cost. But, you know, if you have that rapid drop in temperature, you know, you can kick it over to the electric elements and you've got the quicker recovery.
Yeah, and that, like if you're at Thanksgiving, Christmas time, when you have a lot of people in the house, it'd be a good idea to have it in that hybrid mode, and then you'll have the best of both worlds. Let's talk about electric, and I'm assuming that's just running it with the elements.
Yeah, there's not a whole lot to say about electric. Let's say, you know, the big benefit to you here is, let's say that you put this in and you do have a problem. All right, well, all you got to do is walk over here and hit the mode button until it's on electric, and then hit it again, and now you're heating on the, you know, the backup or the electric elements. I mean, and the unit's still going to, you know, give the customer hot water. Okay. Yeah. The only thing is after 48 hours, it is going to try to go back into the hybrid mode. Okay,
so after 48 hours, if you have it on electric, let's say you really need the hot water, and you put it on electric mode because you do have a lot of people there, and the other modes aren't giving you enough hot water. You put it on electric, after 48 hours, if I forgot, it's actually going to go back to the hybrid mode.
That's correct. I mean, but, you know, let's say it's 3 or 4 days before a technician can come out there, or you just want that recovery. It's as simple as going back to the heater and just putting it back in electric, and it will be back in that mode for another 48 hours.
Okay, and what are we using vacation?
Vacation is simply that, vacation. If you're going out of town, or, you know, you're going to be gone for a few days and you don't want the unit to run at all, you're just going to set it to vacation, and the unit's going to sit there and stand by. Actually, what it's going to do is it's not even going to run unless it sees that tank temperature drop below 70 degrees.
Okay, all right. All right, so those are different modes. Anything special on this controller that we need to keep in mind?
Well, one of the things that's unique about this controller is it will actually give you diagnostics. Okay, so if there is an error, you know, it's going to pop up a code. Now, all you're going to have to do is open up that manual, refer to what the code means, and it's going to give you a plain English, you know, explanation of what that code actually means. Okay, so it's going to say, you know, for example, let's say one of the other features of this control is it actually gives you dry fire protection.
Yes,
so
that was my next point.
So let's say that, you didn't get all the air out of this tank, or it was someone that was new just putting one of these in and they didn't fill the tank and they powered it. Well, because those themistors are there, it's not going to let the element be powered. It's not going to, see that water in the tank and it says no. So you have that, added protection actually built into this control.
So we're looking for that dry fire. And a dry fire is basically not filling the tank all the way up, having air in there. And on a standard electric water heater, the first element that comes on is your upper heating element. It heats the upper 20% of the tank and then throws it down to the lower element once that thermostat's satisfied. So what it's doing is it's monitoring to see if there is there is water and a temperature difference, correct?
That's right.
All right. So, and on a dry fire, if you didn't have that, it's going to burn out the element, and then the water heater won't work. So, we get a lot of calls. We have call centers here, and we get people, homeowners and things like that calling in, saying that they don't have any hot water. They just bought the water heater, and what they did was they didn't fill it all the way up. It's a good idea whenever you install these water heaters is to open up all the hot water faucets for it and let them run free. No spitting and sputtering. Get all the air out of there for 3 minutes. Once it runs free for 3 minutes, then it's time to go ahead and turn on the power. But we're monitoring that on this.
Yeah, the huge benefit to that is, it's actually the most common mistake that we run into on standard residential electric installs. So that's the reason we incorporated it with this guy, is one, it saves you time and effort because, if you've got, one of your guys that you just hired or somebody that's new and they just make a mistake, it's the control is going to protect them from actually dry firing that element. So, that's a huge benefit to the customer.
Now, another thing, too, it takes a little while for this thing to come on initial fire up, too, as well. Like whenever you install it and you turn it on for the actual heat pump to start.
That's right. You have an 8-minute delay, and that was another common call that we get quite often is they would go put one of these water heaters in, and they would fill it, they would purge it, they would turn the power on, and it would just sit there and look at you and do nothing.
Right.
Well, that's normal. It's gonna be 8 minutes minimum. It may be a little bit longer. If your groundwater temperature is really, really cold, it could be longer than that because what's going to happen is, it's automatically going to be in the hybrid mode from the factory. So what's going to happen is it's going to turn the elements on first, and it's going to run them until it gets the water above 59 degrees, and then it's going to let the
Then it's going to kick on that heat pump. All right. Another thing, too, I've noticed is we have inlet and outlet connections on the side as opposed to on the top of the unit. There's a reason behind that because all of the heat pump components are on the top of the unit. If you're putting those, and we're going to show you a picture of the top of the water heater in a moment. We're actually going to go over to a different water heater, take the top off, and show you the inside. But if you have a plumbing leak up top, if you had a leak on one of the fittings or the connections, that can ruin the components up there, and we don't want to do that. So we have two side, an inlet down at the bottom, and then an outlet at the top. Now those inlet and outlet, the outlet actually has a J-tube, and I'll show you more when we go to that other heater, but that J-tube is shaped to where we're pulling the hottest water out of this water heater because, hot water does rise to the top. So, as it's heating, it's going to rise to the top of this unit. We've got a J-tube in there pulling that water off the top, and we'll show you that in a moment. Another thing, whenever we're talking about, heat pump, we're going to condensate, right? That's another thing that's different from electric water heater and this water heater, is we're going to produce condensation. Let's talk about that and how we get rid of the condensation.
Well, one of the side effects of a heat pump is it's actually also going to pull not just the heat, but the humidity out of the air. So, you're going to have condensation as a byproduct. So you're going to have to make appropriations to drain it. The good thing is, though, is it's unlike a gas heater when you hear condensation and it's acidic. Sometimes you have to use, neutralization kits, stuff like that.
Yeah.
This is just water vapor. So you can run it to any drain that you want. You can run it outside and just let it discharge, on the lawn. It's not going to hurt anything. It's not going to discolor the grass.
Unless you have, unless your local code says any different. This is not like, if you have like a condensing water heater. It's actually the water vapor that's in the gas, the fuel. that turns to the condensation, turns into that liquid, and that's what's acidic. On this, we're just taking, it's the ambient air.
Yeah, it's water vapor that's actually in the air.
Yeah, so there's
the actual humidity. So another benefit of that is, especially if you put it in a basement or something like that, is it also dehumidifies and it cools as well, the byproduct.
Yeah, so we'll get cool, dehumidified air for whatever space you have it installed in. That's another thing. I mean, when people talk about this, because it works kind of like a reverse air conditioner, we're putting the heat in the water, and the byproduct is going to be that cooler air. Now, how cool is it going to be, and is that going to, affect the area that it's in?
It will. I mean, you got about a 5-degree drop from inlet to outlet.
Okay.
And basically what you've got, I mean, this is a ballpark figure, but you got about a half ton of refrigeration here.
Okay.
The reason I say it's ballpark, because it really depends on what the temperature is. I mean, if it's, 90 degrees with a relative humidity of 70% outside, you're definitely at that half ton. But, if it's 50 degrees with no humidity in the air, you're probably not getting a complete half ton out of it. And that's another thing to take into consideration is, especially in colder climates, is you want to put this thing somewhere, where optimally the heat pump's going to run year round. Yeah,
that's where you really wanted to look at where you're putting it. Application and sizing. Because with sizing we can overcome some of the, the slower recovery. If we get a large enough tank for the application you're putting it in, you really have to pay attention to how large of a water heater that you're going to need to put in that area. All right, so what we're going to do now is we're going to go over to the other water heater, and we're going to talk a little bit more about some of the features on it, show you some things that are under the hood a little bit, and we'll take our questions over there. So let's go ahead and go over there. All right, we are here. So, since we're taking in the air from the surrounding area where the water heater is, one of the things that we'll have to look at is some type of maintenance will have to be done, as opposed to like a standard electric water heater where they just put it in and they didn't have to really do any kind of maintenance other than, flushing out the water heater from time to time whenever, to flush it out. So that actually increases the life of the water heater.
That's right.
So we're still wanting you to do the same thing with this, flush it out, check those anode rods as well. But let's talk about, some of the maintenance. One of the things is we have an air filter on here. I don't know if we can get a shot of the top. There we go, right there. What is that air filter for?
Well, because we're actually drawing air in from the room and we're transferring that heat, we have to filter, that air, because we don't want debris and stuff like that getting in there. And then also what that's going to do is, that can also lead to a blocked condensate drain.
Right.
Well, people are conditioned to check the filter for, their, central, heating and air for their home. They're conditioned to do that. They're not conditioned to do that so much for a water heater. So this is something that the consumer would need to be educated about. Because if they don't check it, what it's going to lead to is a blocked condensate drain. The good news is we do actually have overflow. So
okay, and then we're going to show you that in a second. One of the things about this, this comes with the water heater. It's installed when the water heater is being shipped. The only thing is, I don't know if we can get a shot. Maybe we can. It's got these tabs. Let me try to get a good angle here. If you can see the tabs right there, there they are. Those tabs will be facing down when the water heater is shipped. The only thing we'll ask you to do is just, pull the filter off and just turn them back upside down, the other way. That way the tabs are facing up, and that's why you can go ahead and grab it and clean it as needed. But let's go ahead and take this off and see what it's protecting.
Well, what it's protecting, you can see all these components here, but basically we don't want all that debris plugging up the evaporator and then
this
going.
Is our evaporator right here.
Yeah, and then going into the drain pan.
Okay.
And clogging it up, because you get all that debris over the evaporator, then you start to make the unit less efficient as well.
Right. Right.
So that's why it's so important to actually clean that filter.
And that's another reason why we have side inlet and outlet connections, because all of our components are up here.
That's right.
Some of our competitors have the top mounted inlet and outlet, and if they have a leak or anything,
all of this is pretty much toast in that case. I mean, right.
Side inlet is good.
Yeah, during the design phase, we looked at both sides of that, and, we just found, one of the more common installation errors or errors that can happen is a fitting leak.
Right.
So we just decided because of that it was in our best benefit and the customer's best benefit to put those connections on the side.
Now, we were talking about this coil actually sits in a drain pan, and we've got an example of one right here. That is what it's setting in. And we were talking about, you've got your connections here. Let's talk about that connection. That's a service item we want to talk about real quick.
Right. What we've run into is because, a lot of guys, what they want to do is they want to torque this thing down really, really tight, and remember, it's not a pressurized drain, it's just a gravity drain. So all you want to do is just hand tighten this thing and maybe go a quarter turn past, because what we run into is, the guys that try to run it all the way down is sometimes they'll end up cracking this condensate drain, and then, you've got the condensation, coming out right here versus going into the drain pipe.
So it's just hand tight and a quarter turn.
Yeah.
Basically. So you've got your main condensate line here. If this gets clogged, you've also got a backup right there.
That's right. This is an overflow.
Let's see if we can get a good shot over there. There we go.
Yeah. You can get just some, vinyl or poly tubing and run that also to a drain. That way, if it ever gets clogged and it has to utilize this overflow, you have a backup. Because if not, if you just leave it open, it's just going to go to the floor.
Right. So where you put the water heater is important. If it's in, say, a laundry room where there's a lot of lint and dust, it can get into the top there. That's why cleaning that filter is important. Doing that periodically, and you won't know really until how long to do that until it's been in there for a little bit, and you can kind of check it like you would your HVAC unit.
Yeah, I mean, people are conditioned to usually check, the filter about once a month on their HVAC unit. Same applies here. This is what we're going to suggest. I mean, obviously if a home, let's say, is not occupied,
right,
and it's not running a lot, then, well, you may be able to get 2 or 3 months. But, the school answer on this is, in general, we want to preach at least once a month, take it off and rinse it off.
Okay. All right, I'm going to show the connection on the condensate now. It's up here on the top, around the back. Let's see if we can get a shot of it. All right, so there's where our connection is going to be. There's a couple wires here. Now, what are the wires for that come out of the back here?
Well, what those wires are for is, this is a condensate pump. A lot of times this guy's in a basement or somewhere like that, and your drains may be overhead.
Right.
Okay? And you can't just punch through the wall. So what you're going to do is you would have to have a condensate pump like this, and what this will do is this will actually pump it up into the drain. Well, these 2 wires right here, see if we can get a shot of those. What they would do, that wire in the back, you would cut that wire, and then you would wire one lead to one side and one lead to the other. What that's going to do is, let's say the float switch in this guy fails, or it fills up and the pump fails, it's going to lock the unit out. That way we don't have condensate spilling all over the floor and doing, potential damage or anything like that.
Yeah, it's going to shut down the compressor part and the top and just kick on the heating element.
That's right. That's
so, so you'll still have hot water if that happens, but it's just going to switch to the heating elements. And then after 48 hours, probably going to try again until that's
it's going to lock it out, and you'll have to go back and push electric again.
Yeah, and another thing too, I want to show you the inlet connection, or an inlet and outlet connection on the back. The outlet connection actually has that J tube. If we can come around, get 5 for me. There we go. There's an arrow right there. Now, on the nipple, there's actually a line. You just line up that line and that arrow, and that J-tube will be positioned correctly. You want to really make sure that it's positioned correctly, because if not, you can have that J-tube positioned a different way, and you won't be getting the hottest water from the tank. Especially if it's turned down, you'll be just getting from the middle of the tank. So that J-tube is just a tube. It looks like a dip tube that's just kind of curled up, and it takes the top part of the tank and the hottest part of the tank.
Well, what's going to happen is if you're trying to put your fittings on there and you torque that nipple and you flip it the other way, what's going to happen is you're actually derating your tank capacity. So you could actually take a 50-gallon and make it into a 35 or a 40 if you don't have it in the right direction. So it is critical that the black line on the nipple does, line up with the arrow on the sticker.
Right. Another thing too, now we have to have electricity to run this. What is our electricity on this? What do we run on? Is it the same as like a standard electric water heater?
That's right. We did that for retrofit applications. That way the only thing you would have to do is just, other than the repipe, because most are going to be on the top,
right.
Is that it'll work on a standard 240 volt service, 30 amp breaker, 10 wire.
Okay.
That's pretty much the industry standard for electric water heaters.
And one of the things I want to talk to you about is, disposal of something like this. I mean, one of the things we talk about is, since it's a heat pump, is there anything different that we can do than a standard electric and gas water heater?
Absolutely, there are different requirements for disposing of this, and this is not a company thing. This is an EPA thing. This is what the Environmental Protection Agency requires. You have to have the proper licenses. What you would do to dispose of this is take it somewhere where you would take a refrigerator or somewhere like that, because by EPA regulations, they're required to actually reclaim or pull that refrigerant out and not let it go to the atmosphere. That's what the EPA dictates to the appliance industry.
All right. So if the way I dispose of my refrigerator, I'll do the same with this. If there's a place that'll actually do that, then you can take it to there. Another thing too is on troubleshooting with these water heaters. We've got call centers here. You can call our 800 number if you do have a problem with any one of our water heaters, and we'll kind of walk you through it. Is there anything special that they're going to be doing with the heat pump part, or how are they handling the calls when it comes to these water heaters?
Well, first of all, we are staffed with some HVAC technicians.
Good.
So if there is a problem on this side, we have the capability and the support to help you over the phone. Mm-hmm. But during the first year, this is one of the things that we're doing that I don't think no one else is doing. If you have a problem with that sealed system in the first year, we're just going to give you a whole new water heater.
Right.
That's how confident we are in it. After the first year, though, we're going to supply you with the part, because we only cover labor during that first year. But what you would do, you probably wouldn't call a standard plumber. You're probably going to call an appliance technician or someone like that.
Yeah. That's what you would do. But we've got calls on this, but we haven't got any really calls on anything that's going on under the hood. We don't get a lot of calls on them at all. Basically, if it's from the top down, right from here down, it works like a standard electric water heater, and they'll troubleshoot that, and they'll take you to a certain point if they do determine that it's up here, and then we'll either get somebody out there that's licensed to do that kind of work and is qualified to do that kind of work. But right now, what we can do is, if you have any questions, we can go ahead and take some of your questions. Just go ahead and call in. One more time. Say that one more time. Okay, well, the question is, what's the life expectancy of the compressor part of the heat pump, and maybe the cost?
Well, the cost information I don't have readily available. In the training department, we don't do pricing. However, I can tell you that the unit comes with a 10-year tank, 10-year parts warranty. That compressor was designed to last 10 years and beyond. Right. It's actually designed to last the life of the tank. Mm-hmm. So, we expect to at least see 10 years out of it, if not more.
I hope that answers your question. Do we have any more questions? Okay. All right, if you do have any problems or with any of our water heaters, like I said, we have call centers here. You can use our 800 number. That's 1-800-456-9805. You can call that number. That's our service. Text over the phone. They'll be more than happy to help you out. One of the things that we do ask is if you do call in, have the serial number of the water heater. They're going to ask you to register the water heater, and then they're going to want to know what you did to the water heater and what kind of codes you're seeing. Okay, I think we got some more questions, so let's go ahead and. I think the question is if you have it in efficiency mode, it will never get to the hybrid mode. I think that's what his question is, if it drops below a certain.
Well, if you set it in efficiency, it's going to try to run just on heat pump only.
Mm-hmm.
So it'll run as long as you stay within the temperature parameters. For example, your air temperature has to be above 45 or less than 109 unless you've got the 50.
Yeah, then it's 120.
Then it's 120. Or, if your water temperature falls, below a certain point, 59 degrees.
Yeah, the tank temperature, right.
At that point, it's going to just lock out. That's the reason we recommend the hybrid mode, because then the control actually will determine which mode is best for you.
Right.
It will actually switch it back and forth.
Yeah, that's the way it works is if in the hybrid mode it sees that 40-degree drop, you're going to be running with the heating elements and the heat pump at the same time. So it's best to run it in that hybrid mode.
If you were in Miami, I would say, yeah, you could throw it in efficiency mode and you would be okay all the time.
Right.
In Cincinnati, I would say definitely hybrid mode
Right.
would be the recommended setting.
Next question. The question is, what type of additional insulation is what you're saying? What additional installation? Okay, what additional installation is required on this rather than on a standard electric water heater?
Right.
Okay, installation.
Well, in a retrofit, let's say you're going from an old style electric to this, one is you're going to have the side plumbing, so you're going to have the retrofits, to that. All right, and then the condensate disposal. You're going to have the condensate drains. You're going to have to run, run condensate drains either outside to a floor drain or to a condensate pump. But that's it.
Well, actually, there's one more too. If you have it in a closet, you're going to have to get air.
True.
So louvers on the door.
That's right.
Put it in an environment that has enough air is really what you're going to look for. So it does take a lot of air. We're going to have to either put louvers on that door, just put a different door on there that can bring in an adequate amount of air. But those really, it's your plumbing lines and your condensate, and then the air that's needed to run the heat pump.
That's right.
Say that one more time. On the weight, what is the weight on the 50-gallon, 66-gallon, and 80-gallon? If you want, I can get those numbers right now.
Yeah, that's not something we can definitely get you that information. That's going to be more like if Jeff, I don't know if he's got
I think I've got it.
A spec sheet or a book with him.
Hold on.
That's going to be in that information.
Yeah, the 50 gallons is 180. The 80-gallon is 259. The short, the tall is 294, and then 244 on that 66-gallon tank. Okay, when it's transported, what do we need to do as far as transporting it? Can it be turned on its side? And I think I know the answer to that. You can lay it on its back. and you got to be kind of careful with it because it'll say to lay it down this way. You can lay it on its back, but you have to look at the box. The box will determine which way you lay it. You don't want to lay it any other way than what it says on the box, but the box will say this way up, I think is what it says on there.
Well, and that's another reason we have that 8-minute delay there.
Right.
Okay, because when they do lay it on its side, what you want to make sure of is you don't lay it on the relief valve side.
Mm-hmm.
You know, if you're going to lay it down, you don't want to lay it down on the side where your water connections are at. You want to lay it down straight back to where, and then you also, I would recommend, strapping it in as well. That way it can't rock back and forth.
You don't want it to move around. So
the reason we have that 8-minute delay is so, when you set it back upright, the heater doesn't come on. That refrigerant and everything has time to
settle. Mm-hmm. The question is, do these units require a vacuum relief valve?
From the manufacturer's standpoint, no, but that's a local code issue, okay? Because that's, would go on your cold water supply, and what that's for is in the event of a leak or something like that in the tank, or something happens with our water supply, it's not draining down. From the manufacturing standpoint, we have a dry fire protection, so from our interest, if you put one in, great, and if you don't, it doesn't make us any difference. But you're going to have codes in particular areas that are going to require it.
Yeah, just adhere to your local codes. The question is, do you recommend expansion tanks? And the answer is always.
Always, absolutely. What we find more and more is that almost everything's in a closed system now, especially in larger municipalities. You still have some rural, areas that don't have closed systems, but it's cheap insurance, okay? Mm-hmm. I mean, an expansion tank is not a great cost, and it's
a properly sized, properly pressurized. There's an expansion tank right there that's on the heater we were standing at before. You want it properly sized and properly pressurized. These are going to be shipped out at a certain pressure, but they have to be pressurized. The air pressure in that tank has to match whatever your incoming pressure is to the house or the application you have it in. You can use a bicycle pump to get it up to the right pressure, but you always pressurize that expansion tank off the system. You don't have it installed and then pressurize it. You're going to pressurize it before you install it. So you're going to check your incoming incoming pressure, and you're going to pressurize the air inside that expansion tank to whatever your incoming pressure is, the highest pressure. So.
Well, and another thing is,
if you're getting in a PRV too.
Well, let's say, also as well, let's say your system's open, okay? We still want the expansion tank. Here's why, because the water meter may come, or the water company may come out and change the meter, and I guarantee you if they do, they have to abide by EPA or the clean water legislation, which states they have to have a check valve in that meter, so it is now going to be closed.
Yes. Yeah, and all that's there to do is whenever that tank heats up, it's there to catch that expansion, and then whenever somebody opens up a hot water faucet, it goes right back in. I think the question is how much refrigerant is in it when it comes from the factory.
It comes with R134A, and it's around 2 pounds.
Is that enough? I guess he's asking the question, is that enough refrigerant for the unit?
Well, I mean, the way that you're going to measure that is actually you're going to have to, check the subcooling and the heating and all that stuff. I mean, you can weigh it, but that's just approximately what it ships with. It's going to be 2 pounds.
What he's asking is that enough for this unit?
Yes, absolutely.
Yes. Okay. I think the question is there any government rebates for this available?
On the federal level, as of right now, no. But on the local level, yes, what we're seeing, depending on the area, there are a lot of local utilities offering rebates on this.
Yeah, so just need to check your local. Okay, the question is, if you have louvers on the door, what is the size? And that's probably have to adhere to your owner's manual.
Well, actually, what I would suggest is not just just put a louvered door on. Mm-hmm. You see what I'm talking about?
Yeah, the whole louvers that run the length of the door. How much air you're going to be able to move.
Yeah, if it's a standard 3.6 or 3.0 door, just put in a louvered door and you're covered.
Mm-hmm. But, parameters like that will probably be in the owner's manual. Will be in the owner's manual. It'll tell you how much you'll need for each water heater. But yeah, that'd be the easiest way to do it, is just put in the louvered door. All right. Well, we really appreciate you tuning in. Hope this answers your question. Again, if you have any problems or anything out in the field, just go ahead and give us a call at our 800 number. You can also email us at help@hotwater.com. But for Kevin Binkley, I'm Jerry Winslet, and we'll see you next time.